The video today is all about proofs involving supplementary and complementary angles. You already know the definition of supplementary and complementary angles. Now I'm going to teach you a few theorems about them and use them in some proofs. First, I need to teach you the angle addition postulate, which you probably already have an idea of, but this is the formal explanation. So it says point D is in the interior of angle ABC if and only if measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So remember, this is a biconditional statement because it uses the words if and only if. So that means it goes both ways. So we can go from the hypothesis to the conclusion, or we can use the converse and go from the conclusion to the hypothesis as well. So basically what it's saying is D is in the interior. So the interior is like the inside of the angle. So anything inside of this angle is the interior of the angle. So it's saying point D is in the interior of the angle if and only if the measure of angle ABD, this angle here, plus the measure of angle DBC, this angle here, is equal to the full angle, angle ABC. This should kind of remind you of segment addition postulate, except with angles. The reason that this picture over here does not work, it's not an example, is because point D is not in the interior. If we looked closely, angle ABD plus angle DBC does not add up to the full angle. Those two angles are overlapping, so this is not an example of angle addition postulate. You have to make sure the two angles only share one side. They are adjacent angles. They do not overlap. Let's try this in a problem. So this one, it's not actually a proof, but it does say to justify each statement. So we still need to write out our statements and our reasons. So we will begin with an equation. We know that the measure of angle 1 plus the measure of angle 2 must equal the measure of angle JKL. The reason we know this is because of angle addition postulate. Next, we can substitute in our values. So by substitution, we can get the measure of angle 1 plus 56 equals 145. Now, in order to solve this equation, I know I must subtract 56 on both sides. Remember, you have to show your work. This is called the subtraction property of equality. Now I can simplify to get the measure of angle 1 equals 89. Double check what they asked you for. They said to find the measure of angle 1. We have completed what they asked us for along with justifying each statement, so we are finished. Please pause the video and try the practice problem below. We will go over the answer to this problem in class tomorrow. Next, I'd like to go over supplement theorem, which is also sometimes called linear pair theorem. Basically, what it says is that if two angles form a linear pair, then they are supplementary. So if we have these angles here, angle ABC and angle DBC forming a linear pair. Remember, the definition of a linear pair is that they are adjacent angles with the non-common sides as opposite rays. Since these two angles are forming a linear pair, we can conclude that angle ABC and angle DBC must be supplementary. We're basically using the law of detachment here. Since they are supplementary, by the definition of supplementary, you would always be able to go ahead and say that the measure of angle ABC plus the measure of angle DBC equals 180. That's by the definition of supplementary. There's a similar theorem for complementary angles called complement theorem. It says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. So for example, if we are given that angle EFG and angle GFH are adjacent angles and the non-common sides form a right angle, we can conclude that angle EFG and angle GFH are complementary. Therefore, by the definition of complementary, you could always use this as your next step. You could always say the measure of angle EFG plus the measure of angle GFH must equal 90 by the definition of complementary. Let's use this in an example. It says angle 6 and angle 7 form a linear pair if the measure of angle 6 equals 3x plus 32 and the measure of angle 7 equals 5x plus 12. Find x, the measure of angle 6, and the measure of angle 7. Justify each step. I went ahead and drew a picture here for us to look at. Remember, they're forming a linear pair, so they are adjacent angles whose non-common sides are opposite rays, so that looks like the picture I've drawn here. Now let's go ahead and write out the answer to this. So since angle 6 and angle 7 form a linear pair, I can first say angle 6 and angle 7 are supplementary. By the linear pair theorem / supplement theorem. You only need to call it one name, so if you like linear pair theorem better, go ahead and call it that. If you like supplement theorem better, you can go ahead and use that name. Like we already said, we can move directly from this to the statement that the measure of angle 6 plus the measure of angle 7 equals 180 by the definition of supplementary. Now, in order to find the value of x, we should substitute in the expressions for each angle. So I know the measure of angle 6 is 3x plus 32, and I know the measure of angle 7 is 5x plus 12. In order to solve this equation, the first thing I will do is combine like terms. So I'll get 8x plus 44 equals 180. Next, to get x by itself, the first step is to subtract 44 on both sides. Subtracting the same number on both sides is known as the subtraction property of equality. This will simplify to 8x equals 136. Now to get x by itself, I need to divide by 8 on both sides. This is called the division property of equality. Which I can simplify to x equals 17. I found the value of x. Now I also need to find the value for the measure of angle 6 and the measure of angle 7. So I'll have to substitute it back in. So I have the measure of angle 6 equals 3 times x, but instead of x, I'm going to plug in 17. And the measure of angle 7 is equal to 5 times x, but instead of x, I'll use 17 plus 12. So this is by substitution that I know this. Finally, I can simplify to my final answers to say that the measure of angle 6 equals 83 and the measure of angle 7 equals 97. How could I check this answer? I know that I can check it by making sure that these two numbers, these two angle measures, add up to 180. Does 83 plus 97, is that equal to 180? Yes, it is. So I know I probably have my answers correct. Finally, for your reflection question today, please answer this question. How do you know when to use the supplement theorem versus the complement theorem? Please explain your answer in 1 to 2 complete sentences.